If you're in business today, you're in the business of data. So much data, and so many new ways to think about it. But what is it worth if you don't have the innovation to put that data to work for you? When big data and analytics, cloud and mobile are changing the way business is done, when companies are trying to uncover insights from the ever-increasing amount of data being generated, and data centers are struggling to manage this data even with more and more servers, IBM has created a new system that's designed for big data, optimized to deliver better cloud economics, and built with open innovation to turn these powerful forces into a competitive advantage. Introducing Power Systems, featuring the new Power 8 processor. Let's take a look at how IBM Power Systems' open innovation puts data to work. Imagine this. A customer, armed with the local mall's Frequent Buyers Club app on his mobile phone, goes shopping. As he enters the mall, facial recognition software identifies him and lets his favorite retailers know he's in the vicinity. These retailers can now send personalized offers based on his purchase history to his mobile phone. How does this work? As cameras scan the customer's facial features, the image and instructions to analyze and identify it are sent into one of the mall's Power 8 servers. Then, the data packets enter one of the two Power 8 microprocessors through a PCI port. From here, the Power 8 processor distributes the instructions and data, and the recognition software, designed to take advantage of the massive parallelism of the Power 8 architecture, crunches the data using the 12 cores and a special hardware accelerator available per socket. Using the system's memory and solid-state flash, the recognition software creates an in-memory database. This database can now be run with 24 cores and 2 accelerators in parallel to identify the man's facial image from hundreds of millions of images in the database. These Power 8 accelerators are custom designed to speed up the most frequently used functions in the facial recognition code. Each accelerator is connected to a microprocessor via the new Coherent Accelerator Processor Interface, or CAPI, a first of its kind in the industry. This interface allows the accelerator to read and write to the cache and memory hierarchy with the same rights and privileges as a core. This new technology leads to performance gains that allow the system to match the customer's image to his profile the instant he steps into the mall. This performance gain is clear when you compare a CAPI to a non-CAPI accelerator. CAPI saves time by taking fewer steps and bypassing the need to go in and out of the PCIe engine. As the image analysis is completed, both Power 8 processors continue crunching other instructions with each of their 12 cores, each one packing a big punch of processing power with the help of 2 mechanisms, the first being more parallelism. Inside each core, the data path and processing engines are almost twice as wide as Power 8's predecessor and over 2.5 times as wide as commodity x86 processors, allowing more data to be processed per tick of the clock. The second mechanism is simultaneous multithreading, or SMT, an IBM technology like no other. This technology allows each core to appear as multiples to the software. Power 8 has 8 threads per core, while conventional servers top out at 2. These 8-thread cores are used to assemble the customer profile and create buying recommendations based on past purchases and other data. Now let's return to our shopper and see how Power 8's open innovation and the Open Power Foundation can make this shopping experience a reality. By combining the remote direct memory access with 40 gig Ethernet network technology from Open Power member Mellanox, the mall data center can replace 9 servers with 1 Power 8 server due to the 10 times increase in throughput. With the simplicity of a plug-in card, this technology frees up space that was dedicated to the I/O for more scale-out compute. So this futuristic retail experience can be possible for not just one, but for thousands of shoppers at one time. Not only will this card provide a 10-time increase in bandwidth, but also a 7-time reduction in latency, or time for data to travel from point A to point B. So, a data packet that once took 1 second to send from a client to a server will now take only 140 milliseconds. Our power-enabled shopping mall of the future will perform advanced analytics for the benefit of all shoppers. Analytics that reveal trends, offer discounts, and customized shopping experiences based on shopper preferences and behavior. Advanced analytics programs are often written in Java. Power 8 technology combined with an Open Power Foundation members technology can increase Java performance by up to 8 times. How? Compiling Java code using NVIDIA's CUDA parallel computing platform enables the code to run on an NVIDIA graphics processing unit accelerator. As a result, retailers could obtain a rich customer profile and developed personalized offers in 1 minute, when before it may have taken 8. With buying decisions often made in seconds, this technology could be the deciding factor on whether a purchase is made or lost, simply by inserting an open power NVIDIA GPU accelerator into any Power 8 system. This also dramatically reduces expense and time to market by eliminating the need for armies of Java programmers to spend months optimizing thousands of lines of code. This is good news for coders because now they're free to work on more creative and innovative projects. And the mall can also increase ROI from their analytics initiative. All made possible by just-in-time analytics algorithms compiled and run on Power 8 servers containing NVIDIA GPU accelerators. An important technology that brings mobile and the compute-intense analytics world together is the key value store function and its huge, unstructured databases. The power-enabled shopping mall will benefit from the pairing of 2 advanced IBM technologies, CAPI and Flash. It's easy to imagine our advanced shopping technology constantly matching sets of data collected in a variety of ways and none of that data having the same formatting. Database technology known as NoSQL is used to process unstructured data in applications. By combining a Power System server with an IBM 12 terabyte flash enclosure and a plug-in card with an FPGA, we're able to create in-memory databases that were once unthinkable for scale-out servers. Conventional equipment would take more than 12 times as much space, 12 times the energy, and 2 times the cost. As the mall collects more and more data, the data center can improve big data and analytics performance with Power 8 scale-out clusters as business requirements grow. These Power 8 clusters provide significant agility and time to value with a 4-time reduction in storage, 2 times the storage bandwidth, and 2 times less in storage costs, simply by implementing compression and decompression acceleration on Open Power member Altera's FPGA accelerator. These technologies help turn growing data into real-time insights by allowing access to any data object from any server with a data-centric system-level optimization and acceleration. And all of these customized shopping experiences could be available on-premise or through the cloud. So as you can see, this new, groundbreaking, and powerful technology was not only designed for big data, it was built to transform business, your business, in a way no other system can, with open innovation to put data to work. Today, it's possible with Power Systems.